For 150 million years, they were masters of the Earth, giants of unimaginable scale whose footsteps shook the very ground. Then, in a single, catastrophic moment, their reign was brought to a fiery end. An asteroid, a 6-mile-wide harbinger of change, struck the planet, plunging the world into a long winter. The age of reptiles was over. In the silence that followed, amidst the ash and ruin, a new story began. From the shadows, from burrows deep beneath the altered earth, the survivors emerged. They were small, unassuming, creatures of the night. But in their veins flowed the legacy of resilience and the promise of a new dynasty. This is the story of how our most distant ancestors inherited a shattered world and forged a new one in their image. This is the dawn of the Age of Mammals. 66 million years ago, the Earth was a paradise of giants. This was the late Cretaceous period, the zenith of a reptilian dynasty that had lasted for over 150 million years. Vast, shallow seas teemed with colossal marine reptiles, while on land, dinosaurs of every conceivable shape and size dominated every ecological niche. A Tyrannosaurus rex, the apex predator of its time, patrolled the temperate forests of North America, its thunderous footsteps a regular part of the planet's rhythm. Herds of Triceratops, armored and formidable, moved through the undergrowth, while long-necked Alamosaurus browsed on the tops of ancient conifers. The air itself was alive, filled with the leathery wings of pterosaurs and the buzz of primitive insects. The world was loud, vibrant, and stable. The climate was warm and humid, with no polar ice caps and forests stretching to the poles. Life, in its grandest and most imposing form, seemed eternal. But beyond the familiar blue sky, an interstellar traveler was on a collision course with destiny. A piece of rock, an asteroid estimated to be 10 kilometers wide, was moving through the solar system at a velocity almost impossible to comprehend. For millions of years, it had traveled its silent path, but now its trajectory intersected with that of our world. On that final day, it would have first appeared as a new, unnaturally bright star in the daytime sky, growing in intensity with each passing hour. The great dinosaurs, with their sophisticated senses, might have noticed the strange light, but they would have had no context for the peril it represented. It was an event entirely outside their evolutionary experience. There was no instinct for a threat that came from the cosmos. As the asteroid screamed through the upper atmosphere, it became a pillar of pure fire. In the final seconds, it compressed the air in front of it into a plasma hotter than the surface of the sun. The impact, when it came, was not merely an explosion. It was a geological event on a planetary scale. It struck the shallow sea off the coast of the modern-day Yucatan Peninsula with the force of billions of atomic bombs. The initial flash of light and thermal energy was instantaneous and immense, incinerating a vast radius in a fraction of a second. The ground itself behaved like liquid, creating a transient crater over 100 kilometers wide and 30 kilometers deep. Trillions of tons of vaporized rock and asteroid material were ejected high above the atmosphere, destined to fall back to Earth as fiery rain. For the creatures near the impact zone, the end was swift. But for the rest of the planet, the day the sky fell was only the beginning of a long global nightmare. The world they knew was about to be unmade. The immediate aftermath of the Chicxulub impact was a global inferno. The superheated material thrown into space rained back down across the planet, raising air temperatures to oven-like levels and igniting continent-spanning wildfires. But this searing heat was a prelude to an opposite, more enduring catastrophe. The immense volume of pulverized rock, soot from the fires, and sulfur compounds from the impact site were blasted into the stratosphere, where they formed a thick, impenetrable shroud around the entire globe. The sun, the source of all energy for life on Earth, was blotted out. Day turned into a perpetual, murky twilight, a dim, featureless gloom that would persist for months, possibly even years. The world was plunged into a profound and chilling dusk. With sunlight unable to reach the surface, the planet's thermostat plummeted. This was the impact winter. Temperatures fell dramatically, bringing freezing conditions even to tropical latitudes. For the cold-blooded dinosaurs and other reptiles that relied on external heat to regulate their bodies, this sudden, relentless cold was a critical blow. But the most fundamental consequence was the collapse of the food chain at its very foundation. Photosynthesis, the process by which plants convert sunlight into energy, ground to a halt. In the oceans, the plankton that formed the base of all marine ecosystems perished in the darkness. On land, surviving plants withered and ceased to grow. The great herbivores, the triceratops and the duck-billed hadrosaurs, soon found their food sources vanishing. Without the herbivores to hunt, the carnivores, including the mighty Tyrannosaurus, were also doomed. The intricate web of life, woven over millions of years, was unraveling with terrifying speed. Acid rain was another consequence of the atmospheric contamination. The vaporized sulfur from the impact zone mixed with atmospheric water to create torrents of sulfuric acid. This toxic precipitation poisoned lakes, rivers, and the surface layers of the ocean, presenting a severe challenge for any creature with a shell made of calcium carbonate, like ammonites, and many types of plankton. The world became a grim, hostile place. The vibrant greens of the Cretaceous were replaced by monotonous shades of gray and brown. The air was thick with haze, the water was acidic, and a deep, unnatural cold settled over the land. Life was being squeezed from all sides by a combination of factors it had never before encountered. Any organism that hoped to survive this new, twilight world would need more than strength or size. It would need an entirely different set of skills and an extraordinary amount of luck. As the dust began to settle, both literally and figuratively, the true scale of the devastation became apparent. The world that emerged from the long twilight was an unnervingly quiet one. The cacophony of the Cretaceous was gone. The deep, resonating calls of giant herbivores, the piercing cries of pterosaurs, the terrifying roars of apex predators, all had vanished. A profound silence had fallen upon the earth, broken only by the whisper of the wind and the trickle of poisoned water. This was the KPG extinction event, a biological crisis that erased an estimated 75% of all species on the planet. The fossil record tells a stark story. In the rock layers below the impact boundary, there is a rich diversity of life. In the layers immediately above, there is an emptiness. It is a geological scar, a clear and unambiguous line between two different worlds. No land animal weighing over 25 kilograms survived. The non-avian dinosaurs, after a reign of more than 150 million years, were gone completely. Their size, their specialization, and their high metabolism, which were once the keys to their success, became their undoing in a world stripped of resources. The larger the animal, the more food it needed, and in the post-impact world, there was simply not enough to sustain them. The great marine reptiles, the mosasaurs and plesiosaurs, also disappeared from the oceans, along with the coiled-shelled ammonites that had been so abundant. The extinction was selective. It did not strike randomly. It favored the small, the generalist, and the adaptable. Creatures that could hide, hibernate, or sustain themselves on the detritus of a ruined world had a fighting chance. Anything large, specialized, or directly dependent on fresh vegetation was systematically eliminated. This great silence represents one of the most significant ecological vacuums in the history of life. All the major niches occupied by the dinosaurs were now empty. The roles of large herbivore, medium-sized browser, and apex predator were vacant. For millions of years, the evolutionary stage had been dominated by a single, spectacular cast of characters. Now, the stage was clear. The script had been torn up, and the future was unwritten. The planet was a blank slate, a world of opportunity for whichever group of survivors could seize the moment. In the eerie stillness of this new era, the first stirrings of a new dynasty were beginning. Hidden in the shadows and beneath the soil, small furry creatures had weathered the storm. Their time was coming. The great silence was not an end, but a quiet, uncertain beginning. In the first centuries and millennia after the impact, the world's recovery began not with animals, but with plants. The complex flowering plant ecosystems of the late Cretaceous, the vast conifer forests and the emerging broadleaf woodlands, had been decimated by the global wildfires, the lack of sunlight, and the acid rain. As light slowly returned to the planet's surface, the first plants to recolonize the barren landscape were not the mighty trees of the past, but the humble and opportunistic fern. Geologists see this event clearly in the fossil record. Immediately above the iridium-rich clay layer that marks the impact, there is a sudden and dramatic spike in the abundance of fern spores. This fern spike is a global phenomenon found in rock formations from North America to New Zealand, signaling the rise of the world's first post-apocalyptic ecosystem. Ferns are pioneer plants, perfectly adapted to thrive in disturbed environments. Their spores can travel long distances on the wind and can lie dormant for extended periods, waiting for the right conditions. In the ruined world of the early Paleocene, they found those conditions everywhere. With the great forests gone and the soil stripped of competitors, ferns grew unchecked, carpeting the landscape in a monotonous, seemingly endless sea of green. This was not a diverse, vibrant ecosystem, but a low-diversity, homogeneous world. Imagine a planet shrouded in mist, where from horizon to horizon, the only vegetation is a dense blanket of ferns. It was a strange, alien landscape, a far cry from the rich tapestry of the Cretaceous. This kingdom of ferns was a transitional phase, a planetary scab forming over a deep wound. While this fern-dominated world lacked the complexity of what came before, it was critically important. The ferns stabilized the damaged soils, preventing mass erosion. They restarted the process of photosynthesis on a global scale, slowly pumping oxygen back into the atmosphere and re-establishing a base for the food web. Their decaying matter created a new layer of nutrient-rich topsoil, paving the way for other, more complex plants to eventually return. For the animal survivors, this new world presented a strange new reality. It was a world with plentiful ground cover, offering hiding places from avian predators like the newly evolving birds. But it was also a world with a limited menu. The first mammals to emerge into this landscape had to be generalists, capable of eating insects, worms, and whatever else they could find amongst the fern roots. The kingdom of ferns was a temporary one, but it was the essential first step in the planet's long, slow journey back to health, setting the stage for the next chapter of life's story. Who were the inheritors of this broken world? The answer lay not among the mighty, but among the meek. While the dinosaurs ruled the day, another group of animals had been quietly thriving in the shadows for millions of years: the mammals. Throughout the Mesozoic era, our distant ancestors were small, often nocturnal creatures, living in the margins of the dinosaurs' world. They were shrew-like, rat-like, or squirrel-like in appearance, rarely growing larger than a modern badger. They scurried through the undergrowth, hunted insects by night, and often lived in burrows. This humble, secretive lifestyle, developed over eons of living in fear of giant predators, turned out to be the perfect survival kit for a planetary catastrophe. Their small size was a crucial advantage. A small body requires far less food to survive, a vital trait in a world of scarcity. Their diet was often generalist. Many ate insects, worms, seeds, and roots, all of which were more readily available in the post-impact ecosystem than fresh vegetation. Their warm-bloodedness, or endothermy, allowed them to remain active in the chilling temperatures of the impact winter. Perhaps most importantly, their burrowing habits provided the ultimate shelter. By digging into the soil or hiding in deep crevices, they could insulate themselves from the initial heat blast of the impact and the subsequent freezing cold. While the world above was being remade by fire and ice, these creatures were safely tucked away, waiting out the storm. Among these survivors was a group of early placental mammals. A creature like Purgatorius, found in the Hell Creek Formation of Montana, represents what these survivors may have looked like. Small and vaguely squirrel-like, it was an agile climber, likely feeding on insects and fruit. It was not imposing, but it was adaptable and resilient. As the ferns gave way to recovering forests of flowering plants, creatures like Purgatorius and its relatives emerged from their hiding places into a world of immense opportunity. The great reptilian gatekeepers were gone. The ecological stage was empty. For the first time in their evolutionary history, mammals were not living in fear. They could now walk in the daylight without the constant threat of a Tyrannosaurus. This was their moment. From these small, unassuming survivors, an explosive evolutionary radiation would begin, a diversification that would eventually give rise to the vast array of mammals we see today, from bats to whales, from horses to humans. The age of reptiles was over. The age of mammals had begun. The great impact winter has passed, but the world is not reborn in vibrant color. It is a world of gray ash and green opportunism. Vast forests of ferns, the first plants to recolonize the wounded earth, stretch for miles under a hazy sky. This is the early Paleocene, a planet scrubbed clean of its former masters. And in this quiet, empty world, life stirs not with a roar, but with a rustle in the leaf litter. Our ancestors, the mammals who made it through the cataclysm, were not giants. They were creatures of the shadows, small, furtive, and built for survival. Imagine a world where the loudest sound is the drone of insects, where the greatest danger is not a towering predator, but a sudden flood or a winter of scarcity. For these survivors, the planet was an immense, open frontier. The ecological roles once held by 100 dinosaur species were now vacant. It was a lottery of opportunity. Among these pioneers was a creature known as Purgatorius. No larger than a rat, with teeth adapted for a diet of insects and fruit, it represents a critical junction in our own deep history. As a Plesiadapiform, it belongs to the group that would eventually give rise to all primates, including us. For now, its world is the forest floor and the low-hanging branches of the new flora. It navigates a landscape of decay and renewal, its senses tuned to the snap of a twig or the scent of a fallen fruit. This was not an age of mammalian conquest, but of quiet persistence. These animals were generalists, able to eat whatever they could find, and specialists in the art of staying hidden. They burrowed in the ash-laden soil and made homes in hollow logs, living out their lives in a world that was, for the first time in 150 million years, free from the crushing pressure of the dinosaurs. They were the inheritors of a silent kingdom, unaware that their descendants would one day reshape the planet. Their legacy was not in their size or strength, but in their simple, profound ability to endure. From these humble beginnings, an evolutionary explosion was about to be ignited. With the tyrants of the Mesozoic gone, the stage was set for a new cast of characters. The first few million years of the Paleocene were not just about survival, they were about opportunity. Life abhors a vacuum, and the mammals, for so long relegated to the wings, now stepped into the spotlight. This was the first dawn of their age, and evolution began to work at a feverish pace. From the handful of lineages that survived, a bewildering array of new forms began to emerge, a process known as adaptive radiation. Among the most successful of the early pioneers were the multituberculates. These rodent-like mammals were not newcomers. Their lineage stretched deep into the age of dinosaurs. But now, without competition, they flourished. With their distinctive multi-cusped teeth, they became the dominant small herbivores, filling niches that squirrels and mice occupy today. They scurried through the undergrowth and climbed the strange new trees, a testament to the success of an ancient design. At the same time, another group was making its first tentative steps towards greatness, the condylarths. This was not a single family, but a collection of archaic, generalized hoofed mammals. They were the evolutionary testbed from which many modern groups would spring. Creatures like Protungulatum were small, no bigger than a raccoon, with 5-toed feet that were neither true paws nor true hooves. They were jacks of all trades, able to browse on leaves, dig for roots, and perhaps even supplement their diet with insects. They were anatomically simple, but their adaptability was their strength. They represented the blueprint for the future herbivores that would one day roam in vast herds. This era was a grand experiment. Mammals were testing the limits of their forms, exploring new diets and new ways of life. They were still relatively small. A sheep-sized mammal would have been a giant. But the pace of change was breathtaking. In the geological blink of an eye, the small nocturnal creatures of the Cretaceous were giving way to a diverse fauna that was beginning to fill the quiet forests with new sounds and new struggles, laying the groundwork for the world we know today. For millions of years, being big was a death sentence for a mammal. Large bodies were easy targets for dinosaur predators. But in the Paleocene, that ancient rule was broken. With the giants gone, the shadows were no longer a necessary refuge. Emboldened by a world free of immense carnivores, mammals began to explore a new evolutionary frontier: size. This was a radical shift, a declaration that their time had truly arrived. One of the first groups to achieve impressive bulk were the pantodonts. Animals like Barolambda, which roamed North America, were pioneers of largeness. Reaching the size of a modern tapir, with a stocky body, a tiny head, and a thick, powerful tail, it was unlike anything alive today. Its 5-toed, stout-legged gait would have been slow and ponderous. It was not built for speed because it did not need it. In its world, it was one of the largest things around, a walking fortress of muscle and bone. But where large herbivores appear, predators are never far behind. The top predatory roles, once held by tyrannosaurs and their kin, were now being filled by other mammals. The first great mammalian carnivores were not cats or dogs, but strange, archaic beasts. The arctocyanids, or bear dogs, were among the first to specialize in hunting their fellow mammals. Cryacis, for example, was about the size of a fox, with a long body and tail. It was an agile climber, but its feet had small, hoof-like nails, a relic of its herbivorous ancestry. More formidable were the mesonychids, the hoofed wolves. These were powerful pursuit predators, like Disacus, with strong jaws and teeth designed for crushing bone, yet their feet, astonishingly, ended in hooves instead of claws. They were a bizarre and effective combination of features, a testament to evolution's creativity. The dynamic of the ecosystem was fundamentally changing. For the first time, the primary contest between hunter and hunted was an all-mammal affair. The age-old game of cat and mouse was being scaled up, played out in the open, under the sun, by creatures who were finally stepping out of the shadows and into their inheritance as the new rulers of the land. Evolution is not a straight line. It is a sprawling, chaotic laboratory where nature tries out countless designs, most of which are destined for failure. The Paleocene was perhaps the greatest of these experimental periods for mammals. Freed from evolutionary constraints, life-sculpted creatures so strange they defy easy classification, populating the world with biological oddities. This was an age of biological invention, and some of the patents were truly bizarre. Consider the Taeniodonts. This group of mammals took specialization to an extreme. Early forms were small and insectivorous, but their descendants evolved into powerful diggers. Stylynodon was a pig-sized beast with immense forelimbs and huge claws, clearly adapted for excavating roots and tubers. Its most striking feature was its teeth, large, peg-like, ever-growing incisors and canines, their sides coated in a thick band of enamel for strength. It was a creature seemingly designed by a committee, a hodgepodge of features that nonetheless proved successful for millions of years. Then there were the Tylodonts, another evolutionary dead end. They combined the ever-growing, chisel-like incisors of a rodent with the stocky body and clawed feet of a bear. They were powerful herbivores, able to process tough plant matter that other animals could not, occupying a unique niche in the Paleocene forests of Asia and North America. Even the primates, our own ancestors, went through a strange phase. The Plesiadapiforms, while leading to our lineage, produced some peculiar offshoots. Some developed large, gnawing incisors like rodents, while others had elongated fingers, perhaps for prying insects from bark, long before the appearance of the eye in Madagascar. This parade of strange beasts highlights a crucial point. The path to the modern world was not preordained. For every lineage that led to the familiar animals of today, dozens of others embarked on different journeys. These were not mistakes of evolution. They were successful solutions to the challenges of their time. They were bold experiments that thrived in the unique conditions of the early Cenozoic, a reminder that the story of life is filled with forgotten chapters and fantastic creatures that briefly held the world in their grasp. As the first 10 million years after the dinosaurs drew to a close, the world was on the cusp of another profound change. The frantic, experimental energy of the Paleocene was beginning to give way to more familiar forms, and the lines between winners and losers of this new era were being drawn. Two groups exemplify this transition. One, a relic of a bygone age, and the other, a harbinger of the future. The multituberculates, those successful, rodent-like mammals, had dominated the small herbivore niches for millions of years. They were the ghost rats, ghosts of the Mesozoic, a lineage that had walked alongside the dinosaurs and outlasted them. For a time, they were the most abundant mammals on Earth, but their supremacy was being challenged. A new kind of animal was appearing, the first true rodents. These newcomers possessed a key innovation, self-sharpening incisors that were more efficient at gnawing. Faced with this superior design, the ancient multituberculates began a slow decline. Their story is a powerful lesson in evolution. Success is temporary, and even the most dominant group can be pushed aside by a better adapted competitor. While the ghost rats faded, other mammals were scaling new heights. The age of giants was truly beginning. The pantodonts, already large, produced titans like Titanoides. This bear-sized herbivore from North America was a formidable presence, equipped with massive saber-like canine teeth, likely used for display or defense rather than predation. It was a declaration in flesh and bone that mammals were now the undisputed lords of the land. They were no longer just filling the empty spaces left by the dinosaurs. They were creating a new world dynamic, one defined by size, power, and complexity. 10 million years had passed since the Great Extinction. In that time, a world of tiny, frightened survivors had transformed into a planet teeming with bizarre experiments, new predators, and the first true giants of the Cenozoic. The Paleocene was over. The stage was now set for the Eocene, an epoch that would see the rise of the first whales, bats, and horses. The Age of Mammals was just getting started. In the quiet, humid forests of the early Paleocene, a new kind of giant was taking its first steps. The great sauropods were gone, their thunderous footfalls replaced by a cautious rustling in the undergrowth. This was a world of opportunity, a blank slate for evolution to write upon. And one of the first bold signatures belonged to a group of mammals known as the pantodonts. They were pioneers, the first mammals to truly experiment with large body size. Looking at a creature like Pantolambda, one might be confused. It had the stocky build of a small bear, the feet of a badger, and a head that seemed vaguely rodent-like, yet it was related to none of them. Pantodonts were a distinct lineage, an early draft of a large herbivore that arose to fill the ecological void. Their success was rapid and remarkable. Within just a few million years of the extinction event, they had spread across North America, Asia, and Europe. Their primary advantage was their willingness to eat what was abundant: plants. Their teeth were simple, low-crowned, and generalized, not yet the sophisticated grinding mills of later herbivores, but they were effective enough for the soft vegetation of the Paleocene jungles. This diet fueled their growth. While most contemporary mammals were the size of cats or smaller, species like Barolambda could reach the size of a modern tapir, weighing up to 500 kilograms. They were bulky, powerful animals, with thick limbs and broad five-toed feet. They were not built for speed, but in a world where the largest predators were still relatively small, immense size was its own defense. The pantodonts represent a crucial first chapter in the mammalian story of dominance. They proved that mammals could get big, that they could take over the role of primary consumers on a grand scale. They were a testament to life's incredible ability to innovate and adapt in the face of unprecedented opportunity. However, they were an early experiment, a first solution to a complex problem. Their generalized anatomy, which had allowed for their rapid initial success, would eventually become their undoing. As the climate changed and more specialized herbivores began to appear, the pantodonts would be outcompeted. They were a dynasty in the making, but their reign would be short. For even as they browsed peacefully in the fern-choked lowlands, another group of mammals was developing an anatomical innovation that would change the course of evolution and pave the way for the future rulers of the plains. While the heavy-set pantodonts lumbered through the forests, a different kind of revolution was happening at ground level, a subtle but profound change in anatomy that would redefine movement for mammals. This innovation belonged to a diverse and sprawling group known as the condylarths. For decades, scientists used this term as a convenient category for any primitive, hoofed mammal that did not fit elsewhere. While the classification is now considered outdated, the animals it described represent a vital evolutionary crossroads. The condylarths were the crucible in which the modern hoofed mammal was forged. Creatures like Phenacodus, a sheep-sized animal from North America, give us a glimpse into this transition. It did not have the single, solid hoof of a horse. Instead, it possessed 5 distinct toes, but at the tip of each toe was not a claw for digging or gripping, but a small, sturdy, nail-like hoof. This was the breakthrough. A hoof provides a solid, durable point of contact with the ground, distributing weight more effectively than a claw or soft pad. It is the ideal adaptation for bearing heavy loads and, crucially, for efficient, sustained running on firm terrain. For the small, often preyed-upon mammals of the Paleocene, the ability to run faster and longer than a pursuer was a ticket to survival. The evolution of the hoof was an evolutionary response to the selective pressures of this new world. Condylarths were incredibly varied. Some were small and omnivorous, scurrying through the undergrowth. Others, like the arctocyanid's, were larger, more robust, and bore a superficial resemblance to bears, with powerful limbs and more carnivorous tendencies. This incredible diversity highlights their success. They were not a single experiment like the pantodonts. They were 100 different experiments happening simultaneously. From this vibrant, adaptable stock would spring nearly all of today's hoofed mammals: horses, rhinoceroses, cattle, deer, camels, and hippos. Even more astonishing, genetic and fossil evidence now shows that whales and dolphins also trace their ancestry back to an early, four-legged condylarth that returned to the water. The first small hooves were more than just a new type of foot. They were the foundation for future empires, enabling mammals to conquer the open plains and even reclaim the seas. But this new, more efficient mode of transport was inextricably linked to the fuel that powered it, and the quest for that fuel would spark an evolutionary arms race that continues to this day. For millions of years, the world's flora had grown largely unchallenged by large browsers. The titanic sauropods were gone, and the vast majority of early mammals were small insect eaters or scavengers. But with the rise of the pantodonts and condylarths, this green, complacent world was about to change forever. A new and intense pressure was being placed on the plant kingdom. Becoming a full-time herbivore is not a simple choice. It is an evolutionary challenge. Plant matter is fundamentally difficult to process. Its most abundant component, cellulose, is indigestible to almost all animals without the help of specialized gut bacteria. Plants are also generally lower in protein and energy than meat, meaning an herbivore must consume vast quantities to survive. To overcome these hurdles, the new mammalian plant eaters began to evolve a suite of remarkable adaptations. The most immediate changes occurred in their mouths. Teeth, once simple pegs for piercing insect shells, began to transform. Molars became broader and more complex, with ridges and crests forming grinding surfaces. These were the first primitive versions of the dental batteries that would allow future horses and cattle to pulverize tough grasses. Jaws became deeper and more powerful to accommodate the muscles needed for hours of chewing. Further down the digestive tract, stomachs and intestines became longer and more complex, creating fermentation chambers where symbiotic microbes could break down tough cellulose. This was the birth of the ruminant stomach and the enlarged cecum. But as the herbivores adapted, so did the plants. This was the beginning of a great evolutionary arms race. Under the constant pressure of being eaten, some plants evolved chemical defenses, producing toxins that made their leaves bitter or even harmful. Others developed physical defenses, such as tough, fibrous leaves, sharp thorns, or tiny, abrasive silica particles in their tissues that would wear down teeth. In response, the herbivores would evolve even more specialized teeth and more robust digestive systems capable of neutralizing the toxins. This back-and-forth dynamic reshaped entire ecosystems. The feeding habits of these new, large mammals determined which plants survived and thrived, altering the very composition of the world's forests. This ever-growing population of plant eaters, converting sunlight and cellulose into muscle and fat, represented an enormous, untapped energy resource. And where there is prey, predators will inevitably follow. The Paleocene was a world of prey. Large, slow-moving pantodonts and increasingly nimble condylarths were turning vegetation into walking larders. Nature abhors a vacuum, and the apex predator niche, left vacant by the Tyrannosaurus and its kin, was the ultimate prize. Mammals, for so long the hunted, were about to reinvent the hunter. Two major groups rose to this challenge, representing parallel experiments in carnivory: the creodonts and the mesonychids. The creodonts were a diverse order that flourished for nearly 50 million years. They were among the first mammals to develop carnassials, a specialized pair of shearing teeth in the upper and lower jaw that acted like scissors, slicing through flesh and sinew with incredible efficiency. This dental innovation is a hallmark of a true carnivore, and the creodonts perfected it. Some, like Patriofelis, were built low to the ground like a massive wolverine, powerful ambush hunters. Others were more slender, built for the chase. They were adaptable and successful, spreading across the globe and dominating the predatory landscape for millions of years. At the same time, the Mesonychids took a different path. From a distance, an animal like Mesonyx might have resembled a wolf, but a closer look would reveal a startling difference. Instead of paws with claws, it had 4 small hooves on each foot, a clear link to its condylarth ancestors. They were literally wolves in sheep's clothing. Mesonychids did not have the slicing carnassials of the creodonts. Instead, their power came from their immensely strong jaws and robust, rounded teeth, designed not for slicing, but for crushing. They were likely powerful pursuers and scavengers, capable of cracking bones to get at the marrow inside. For a time, these two groups were the undisputed mammalian masters of their domain. They were faster, smarter, and more adaptable than the reptilian predators of the past. They could hunt in the cool of the night, their warm-blooded metabolism giving them an edge. They stalked the newly evolved herbivores through dense forests and across emerging floodplains, driving their evolution towards greater speed and social behavior. The age of mammalian predators had begun. But these pioneers were not true carnivorans. They were not the ancestors of today's cats, dogs, or bears. They were a separate, ultimately doomed experiment. And they were not alone at the top of the food chain. They had to contend with a terrifying rival, a living echo from the age of dinosaurs. Mammals may have inherited the Earth, but they did not do so unopposed. Not all dinosaurs had vanished in the Great Cataclysm. One resilient lineage survived, clung to life, and in the strange new world of the Paleocene, it evolved into a new and terrifying form of apex predator. They were the Forus racids, known colloquially and aptly as the terror birds. These were not the ancestors of chickens or sparrows. They were feathered giants, a direct challenge to the supremacy of the new mammalian carnivores. In the Northern Hemisphere, the role was filled by Gastornis. Standing over 2 meters tall and weighing more than 100 kilograms, it was a truly formidable creature. It roamed the forests of Europe and North America, its powerful, muscular legs allowing it to move with surprising speed. But its most fearsome feature was its head. Gastornis possessed an enormous, deep beak, reinforced with bone and powered by massive jaw muscles. For decades, paleontologists depicted this bird as a ruthless hunter, using its beak like a pickaxe to subdue the small, primitive horses and other mammals of the time. The image was compelling, a reptilian holdover asserting its dominance over the upstart mammals. However, more recent scientific analysis has challenged this view. Studies of the beak's structure suggest it lacked a sharp, hooked tip common to modern birds of prey. Chemical analysis of its bones indicates a diet primarily composed of plants. It is now thought that this magnificent beak may have been used for cracking open large, tough-shelled seeds and nuts, or for tearing through fibrous vegetation. But whether it was a fearsome predator or a colossal vegetarian, the presence of Gastornis would have been a constant, intimidating factor for the mammals sharing its habitat. It was a living monument to the former rulers of the planet. Its immense size and power were a clear statement that the age of reptiles was not entirely over. The world of the Paleocene was not yet fully mammalian. It was a contested realm, a battleground between two great dynasties. On one side were the mammals, warm-blooded, adaptable, and rapidly diversifying. On the other were the last scions of the dinosaurs, giant birds of incredible power. The stage was set for a conflict that would last for millions of years, a struggle to determine who would truly rule the new era of life. In the silent, humid world that followed the Great Extinction, survival was a game of shadows. Life clung to the margins, and for our own lineage, it began in the trees. While larger mammals were experimenting with life on the forest floor, A different kind of revolution was happening in the canopy. Here, among the giant ferns and unfamiliar flowers, lived the Plesiadapiforms, a group of small, nimble creatures that represent the very first chapter in the story of primates. At first glance, they might have resembled squirrels, scurrying along branches in the dim, perpetual twilight of the Paleocene forests. But a closer look would reveal subtle yet profound differences. Their claws were slowly being replaced by flattened nails, a crucial adaptation for gripping bark and manipulating food with greater precision. Their snouts were shortening, and their eyes, while still on the sides of their heads, were beginning a slow, multi-million-year migration toward the front. This group was incredibly diverse. Some, like Purgatorius, a tiny animal known from fossils in Montana, were no bigger than a mouse. They lived just after the dinosaurs vanished, feeding on insects and the abundant fruits of the recovering world. They were not yet true primates as we know them. They lacked the forward-facing eyes for stereoscopic vision and the fully opposable thumbs that would define their descendants. But the blueprint was there. Their entire anatomy was being shaped by the demands of an arboreal existence. Grasping hands and feet allowed them to navigate a complex, three-dimensional world with an agility that ground dwellers could not match. A diet of fruit and nectar required a keen sense of smell and, eventually, better vision to distinguish ripe from unripe. This was the critical split. While other mammals were evolving to run faster or grow larger, these proto-primates were evolving to process information. Their world was not one of open plains, but of intricate branches and hidden opportunities. Every leap was a calculation of distance and trajectory. Every meal was a puzzle of finding and handling. They were small, often nocturnal, and lived in constant peril from the new predators of the forest floor. Yet, these humble, shrew-like animals held the key to a different kind of future. In their developing brains and grasping hands lay the potential for curiosity, social complexity, and ultimately, the intelligence that would one day look back and piece together their story. The primate dawn was not a thunderous arrival, but a quiet, cautious ascent into the trees. The extinction event had created a vacuum, a world of opportunity. For the mammals who survived, the planet was an open frontier, a vast and empty stage waiting for new actors. What followed was not a slow, tentative recovery, but a breathtakingly rapid expansion known as adaptive radiation. From their points of origin, mammals began to spread, to explore, and to conquer every available landmass. In the early Paleocene, the continents were arranged differently than they are today. North America, Greenland, and Europe were still connected, forming a supercontinent called Laurasia. This allowed for a great northern migration. Animals could, in theory, walk from modern-day Colorado to Paris. This is precisely what they did. Waves of pioneering species, including the ancestors of hoofed mammals and early predators, spread across this immense territory, adapting to new forests and new challenges as they went. South America, however, was a different story. For much of this period, it was an island continent, isolated from the north. This isolation turned it into a unique evolutionary laboratory. Here, mammals evolved in strange and wonderful ways, free from the competition of the northern giants. Marsupials, which were outcompeted in the north, thrived and diversified, producing saber-toothed predators and other unique forms. Alongside them evolved the xenarthrans, the ancestors of armadillos and sloths. For millions of years, this continent was a world apart, a testament to the power of isolation in shaping the tree of life. Australia, even more isolated, began its own solitary journey, setting the stage for its future as a realm dominated almost exclusively by marsupials. This global conquest was not a peaceful procession. It was a high-stakes race. As groups expanded, they met new environments and new competitors. Land bridges were not permanent highways. They were ephemeral connections that rose and fell with sea levels, sometimes stranding populations, sometimes allowing for new invasions. Every continent became a unique experiment, with different groups rising to prominence based on the specific ecological opportunities they found. Within just a few million years, a geological heartbeat, mammals had transformed from small, localized survivors into a global dynasty. They were no longer hiding in the undergrowth. They were on every continent, in every forest, laying the groundwork for the ecosystems we know today. But as they settled into their new homes, the planet itself was changing. The world was growing warmer, and this global climate shift would present them with their first great test since the asteroid. The world the first mammals inherited was already a warm and gentle place compared to our own. Vast, subtropical forests stretched from the equator nearly to the poles, and there were no permanent ice caps to be found. But around 56 million years ago, the planet's thermostat was turned up dramatically. In a geological flash, an immense amount of carbon was released into the atmosphere and oceans, triggering a period of intense global warming known as the Paleocene-Eocene thermal maximum, or PETM. Global temperatures soared by 5 to 8 degrees Celsius. The oceans became more acidic, causing a crisis for marine life. For the mammals on land, this was a profound challenge, but also a remarkable opportunity. The already lush world became a super greenhouse. Palm trees and tropical vines grew near the poles, and the forests of North America and Europe came to resemble the jungles of modern-day Southeast Asia. This hothouse world forced life to adapt, and fast. One of the most striking responses seen in the fossil record is temporary dwarfing. Across multiple mammal lineages, including early horses and our own primate ancestors, body sizes shrank. Smaller bodies dissipate heat more effectively, a useful trait in a relentlessly hot climate. The PETM also acted as a great engine of migration. As temperatures rose, animals followed their preferred climates, moving toward the poles. This event is believed to be the catalyst that allowed the first modern-looking mammals, including the first true primates, the first horses, and the first even-toed ungulates, to spread rapidly across the northern continents. They appear almost simultaneously in the fossil records of Asia, Europe, and North America, likely having used the warm conditions to cross high-latitude land bridges that were previously too cold. This was not a long-term catastrophe for mammals. In fact, it spurred evolution. The expansion of dense, globe-spanning forests favored tree-dwelling animals like primates, giving them a vast new territory to exploit. The crisis in the oceans may have even encouraged some land mammals to begin exploring aquatic environments, a path that would eventually lead to the evolution of whales. The PETM lasted for about 200,000 years, a brief but powerful fever dream for the planet. It demonstrated how closely life is tied to the global climate and how quickly evolution can respond to environmental pressure. This superheated world, with its endless forests, provided the perfect crucible for the next great evolutionary leap, setting the stage for an even greater explosion of mammalian diversity. With the dinosaurs gone and the world wrapped in a warm green blanket, the first 10 million years of the Age of Mammals were a period of unparalleled evolutionary creativity. It was a time of biological invention, an explosion of forms as mammals raced to fill every conceivable ecological role. The result was a world populated by beasts that would seem alien to us today, a gallery of evolutionary experiments. The role of top predator was quickly claimed by groups like the creodonts. These were some of the first mammals to specialize in hunting, possessing powerful jaws and muscular bodies. They were not cats or dogs, but their own distinct lineage, the first wave of mammalian carnivores to rule the forest floor. Alongside them roamed another strange group of hunters, the mesonychids. Often described as wolves with hooves, These creatures had the powerful heads of predators, but walked on toes that ended in small hooves instead of claws, a truly bizarre combination of features. But the most dramatic changes were seen among the herbivores. The archaic hoofed mammals, known as condylarths, were a diverse group that included the ancestors of many modern orders. They were the raw material from which future horses, cattle, and even whales would be sculpted. For now, they were generalists, adapting to a life of eating plants, and some of them got very, very big. This was the era of the first mammalian megafauna. Creatures like Barolambda, a heavily built pantodont from North America, reached the size of a bear, with a thick tail and powerful limbs. Even more spectacular were the Dinosaurata, or terrible horned mammals. Uintatherium, which appeared slightly later, was a rhino-sized behemoth with a formidable array of bony knobs on its skull and a pair of long, saber-like canine teeth. These were the first land animals in millions of years to achieve such immense size. They were living proof that mammals could now command the landscape, no longer confined to the shadows. This 10-million-year burst of innovation established the blueprint for modern ecosystems. For the first time, the world was filled with mammalian browsers, grazers, hunters, and scavengers. Many of these early pioneers, like the pantodonts and mesonychids, were evolutionary dead ends. They were successful for millions of years, but would eventually be replaced by more efficient and specialized designs. Yet their brief time on the world stage was critical. They were the first draft of the modern world, a bold and sometimes strange testament to life's incredible ability to innovate and diversify in the face of opportunity. 10 million years. In that short span of geologic time, the world had been utterly remade. The dust from the asteroid had long since settled, and the silence left by the dinosaurs had been filled by a cacophony of new sounds. This was a planet ruled by mammals. They had survived the apocalypse, spread to every corner of the globe, and exploded into a bewildering array of forms, from tiny, tree-dwelling primates to hulking, rhino-sized herbivores. They had proven themselves to be masters of adaptation, turning a global catastrophe into the ultimate opportunity. But the world they had built was just the first act in a much grander play. The bizarre beasts of the Paleocene, the creodonts, the pantodonts, the hoofed predators, were pioneers, the first wave to claim the empty world. Like all pioneers, many were destined to be replaced by those who came after. Their evolutionary experiments, while successful for a time, were about to face new competition from more modern, more refined designs. As the Paleocene gave way to the Eocene epoch, the global greenhouse climate persisted, but new players were entering the stage. These were the ancestors of the animals we know today. The first members of the order Carnivora appeared, smaller and more agile than the creodonts they would eventually supplant. They were the progenitors of all cats, dogs, bears, and seals. The first perissodactyls, small, graceful animals like Hyracotherium, the dawn horse, began their long journey toward the powerful runners of the plains. And the first artiodactyls, the ancestors of deer, antelope, and camels, made their debut. In the canopy of the world-spanning forests, our own distant relatives were also changing. The primates were no longer just squirrel-like generalists. They had developed forward-facing eyes, granting them true depth perception, a vital tool for leaping through branches. Their brains were growing in complexity, and their social lives were likely becoming more intricate. The first 10 million years had been a chaotic, inventive, and absolutely essential period of foundation laying. It was a time of recovery and experimentation, of evolutionary dead ends and brilliant new beginnings. The shock of the extinction was over. The stage had been built, the basic roles had been cast, and the ecological rules had been written. Now, the main characters of the Age of Mammals were ready to make their entrance, and the world they would inherit was primed for dramas, innovations, and transformations that would ultimately set the course for our own existence.